All right, lesson 7.6, elementary series, alternating series. There are 4 foundational series that you have to have memorized. And I'm going to write them out right now, and you need to know them and their power and their pattern. So for sine x, the pattern of the series is x subtract x cubed over 3 prime, x to the 5th over, and if you like, you can think of it as 1 over 1, like this, so you can see the pattern. Oops, it's subtracting. And so on. So how will I remember sine x is this? First of all, is it alternates, kind of like sine that goes up and down, up and down, up and down, and it's odd. So 1, 3, 5, 7, 9 over their factorials. Cosine, I wonder if you can see the pattern here. So in this case, think of the first one as x to the 0. And so if it's x to the 0, believe it or not, 0 factorial is equal to 1. I know it doesn't make sense, but it does. 0 factorial is 1. So x to the 0 over 0 factorial is actually 1, and then 2, and then 4, then 6, then 8, and so on. Very similar, right? They alternate. One has the odd numbers, and one has the even numbers. E to the x, we did this one. This one has the factorial again, all positive. I think this will be the easiest one to remember in terms of the pattern of it. And then ln x is x minus 1. These are similar, right? They're connected, they're inverses. So these 4 you must have memorized. So however you want to think about memorizing these series, that's what we need to do. So what happens when we want to create a new power series based on these 4 that you memorize? So what's sine x squared? So if I know sine, then wherever there's an x, you're going to take all of that and replace it with x squared. So instead of x, it'd be x squared minus x squared cubed over this, and you just follow that pattern. So 4 terms, almost there. And then the general term after that, it alternates. That's how you show positive and negative alternating. And then it's x squared to the 2n plus 1 over 2n plus 1 factorial. That one's trickier. How about cosine the square root of x? So we have to know cosine and then put in root x where there's an x. So it's going to start with 1 minus, and then it's root x squared over 2 factorial, root x to the 4th over 4 factorial, root x to the 6th over 6 factorial. And if we simplified it down, it would just be x over 2 factorial, x squared over 4 factorial. So again, it alternates. And we have the square root of x, and the exponent is even. In the denominator, the factorial is even. Number 3, I'm kind of going into, I got to be careful here. Take e to the x and just multiply everything times x. So that'd be x squared, x cubed over 2 factorial, x to the 4th over 3 factorial, and so on. And then the power series, that it would be x to the n plus 1 over n factorial. 1 over x. I don't see anything here that's 1 over x. So what's connected to 1 over x? And it's here, the derivative of ln x is 1 over x. So 1 over x is the derivative of ln x, which means I would take each one here, and I take the derivative of each one as I go across. So the derivative of x minus 1, the derivative here, you take 2 times that, they cross out, so you have x minus 1. The next one, 3, and the 3's cross out. Oh, make sure you subtract 1 to the exponent, and then you start seeing the pattern. So this is going to be, and it alternates, positive, so negative, positive, negative, positive. Oops. This should be positive, negative, positive. Change this. This should be negative. So it alternates. There is no fraction to worry about. And there you go. All right. I made it n minus 1, so when you plug in 1, the answer is 1. How about this one? Obviously, this one's connected to ln x, and we're integrating each term. So if I integrate this, I get, you add 1 to the exponent and divide. You add 1 to the exponent and divide. So sorry, add 1 to the exponent and divide, that makes it 6. Add 1 to the exponent and divide, that makes it 12. And so on. So they alternate. Oh, and it's t. And then when I plug in t, all of these is changed to t. I should have had one more, right? It's 20. And there you go. All right, an alternating series is a series whose terms go from positive to negative to positive to negative, between positive and negative. 3 of the 4 elementary ones, these 4 that we need to know, go positive, negative, positive, negative. The only one that doesn't is e to the x. So there is a test of convergence if it's alternating. And so test number 1 is, it must be decreasing. When you look at the absolute value of every term, it must be decreasing. And the limit, the right end behavior, must be going to 0. So if I plug in 1, negative 1 to it's positive, and then it's going to be negative, then it's positive, and negative, and you can see what's happening. So the absolute value of every term, is it getting decreasing? And the answer is yes. The limit as n approaches infinity of this so negative 1 to whatever, I'm not worried about, but 1 over n, is that going to infinity? So when the bottom is more powerful than the top, it is. And so it meets both criteria. And we call this the alternating series test. So the absolute value of every term is decreasing and the limit is going to 0. By the alternate series test, this converges. Number 7, if I plug in 1 and then 2 and then 3 and so on, this is going to fail So as I So n plus 1 divided by n. So n divided by n, dividing the power terms, the n behavior is not 0. The bottom would need to be more powerful than the top. They're the same. So this diverges, and the reason it diverges is the nth term test. So we now have another test to consider. So the nth term test here, the limit must be going to 0 for the series. The geometric test, the common ratio, must be between -1 and 1, or the absolute value greater. If it diverges, if it's bigger than 1, it converges if it's less than 1, and we have this formula a over 1 minus r. The alternating series test is the one we just looked at. So the absolute value of every term decreases, and the limit goes to 0 both. If that happens, then it does converge. All right, Mr. G Math over and out. Till next time, let's do our assignment together.